You could talk about factoring. We could give you a factoring problem.
No, don't do it.
Yes. Yes.
Yeah. Grayson, you have to.
Okay.
Okay, I got this. Give me an easy
Let's
one.
go.
Please.
Oh, some Coke to give him. Oh, Dr. Pepper.
Dr. Pepper. Where's the?
There we go. Yes.
Okay. Class with this problem.
This video is sponsored by Dr. Pepper, by the way.
I think you can get it taken down on YouTube if you're not actually
Dang. It's what two factors of something make this?
Alright.
I don't remember what factors of what, but I remember that.
Okay, let's do it.
So is it factors of 6?
Oh.
Factors of. Okay, I do know it's this.
Oh, there we go. Good.
You're getting this one right?
Yes.
Now it's these that I don't know.
He's on the right track.
What wait, watch
No,
this.
he's going.
Watch this.
Hold on.
5.
No, wait.
Okay.
Yeah.
Okay.
Right?
So now foil it and see if you're right.
Am I right?
Foil it.
What do you mean? How is this not right? I don't want to foil it. That takes some time. I like foil, but how's this not right?
Like tinfoil?
Grayson, when you multiply the 5 by the x, and then you multiply the 1 by the other x, and then you add those together.
You get 6, not 5.
Yes.
Right. And when you multiply the 5 by 1, you get 5, not 6.
So it's 2 and 3.
I don't know. Foil it.
Oh my gosh. Just tell me. I don't
So
know.
x times x. What's x times x?
Equals to 0.
Okay, hold on. X squared. 5x. Yeah.
Yep.
Hey!
Yeah.
You got it.
Hey.
Let's go!
I did it with one bad attempt.
You did it?
Yeah, I did it. There it is.
Oh boy.
You're welcome. Now we all know how to factor.
And you'll get free Dr. Peppers with your promo code X+3,
Walker.
X+2.
Click my referral link in the description to get 10% off your next 3 orders of Dr. Pepper.
With a side of wag bags.
Oh my, with the side wag. It's okay.
I don't think Preston and Preston are actually gonna watch the
Look
video.
at that. I wrote 5 and 1 originally, but oh well.
Yeah.
Thanks, Grayson.
Yeah, you're welcome. Goodbye, everyone.
Bye.
Okay. So we were. Where were we? Yeah, where were we?
Where am I?
Where am I? That is the right question. Where am I? We had finished talking about that. Okay, yes, 7.4 is what we're getting into. And 7.4 is going to talk about reference angles, and then it's going to also talk about the rest of the unit circle in terms of our specialty values on the unit circle. In the unit circle, we've already talked about, eraser here. The unit circle, we already talked about the zeros, the pi over 2s, the pi's, the 3 pi over 2s, right? And the 2 pi's. We already talked about all those, talked about them in terms of sine and cosine, right? So we hopefully can make some sense of that. Now, when we go ahead and look at so we'll discuss, let's discuss the next, let's do this first though. So we've discussed that. We're also going to, today, we're going to talk about the 30s or the pi over 6s, the 45s or the pi over 4s, and then the 60s, which would be 2 pi over 6 or pi over 3, so on and so forth. We're going to talk about all those. That's where we're going to go with that. Then we're also going to talk about, okay, this concept here, which is, if I have a 30-degree angle and I make a right triangle there, and we were discussing this yesterday, if I look at that, okay, and I make this right triangle here, then we know we have a 30-degree right angle, this would be a 60-degree. We also know that somewhere over here, the exact same triangle is formed, right? And it would be at a what? This would be a 30-degree angle. What would the angle measure, though, be from here to here? What angle measure is that?
180? Or
150, because it's 180 minus the 30.
Okay, yeah.
We then discussed that the same right triangle is formed, at least in angle measures, but we were discussing, well, this was a positive y, this was a positive x, but now this would be a negative x going this way, this would be a negative y. So there's going to be some differences, but the same triangle, at least the same shape is formed, right? And so we say, okay, all the way over, so 150 degrees also makes that. What makes, we're going to get a lot of arrows and circles going in here, what makes that angle right there?
210.
210, right? 210 degrees, so it's 180 plus 30 more. And then we know there's one other triangle over here with a 30-degree angle there and a 60, right? And what angle measure, going all the way around to here, what angle measure is formed there?
330.
330 degrees, right? And we know that this is still a positive x, but then this would be a negative y as well. So it's a little bit different ratio, positive and negative. The ratio is the same, it's just positive negative difference. So what we actually state here is, you'll notice this 30-degree angle right here, the original 30, it actually refers to 150, 210, and 330. So 30 degrees is actually called a reference angle, okay? And a reference angle refers to 3 other spots on a circle. Now, the 3 other spots in this case, it's a reference angle. It refers to 150, it refers to 210, and it refers to 330. Okay? Any acute angle, any positive acute angle will refer to 3 other angles. So let's, for example, take a look at this one. Let me, done for any positive acute angle. So let's pick one. Let's say it's 50 degrees. So let's say I have a 50-degree angle. And then I would make a right triangle from that, right? Find the other 3 angles that 50 degrees refers to. Just like we did with 30, find them and write them down here. Okay, so we have a 50-degree angle. It's going to refer, that's our reference angle. Okay, that's the reference angle. It's going to refer to 3 other angles. Okay, based off of our, think about what we did with that. It's going to refer to 3 other angles. Okay. We're not really worried about that. We already know the y's and the x's are going to change in terms of the positive and the negative, but the look of the triangle is the same. It's just upside down or to the left or the right, or below, I should say. So what's the first angle that 50 refers to?
130.
130. And then what's the next one it refers to?
Wait, I got 230, but I think that's... No,
230?
Yeah.
Okay. That's right.
Okay. Oh, yeah.
And then 310.
And then 310?
Yep.
310. Yeah, you bet. Because if you'll notice, 130 degrees, what's the angle measure that goes from here to here? 50. If you go 230, okay, so all the way around 230 degrees, what's the angle measure here? 50. And we go all the way around to what, 310?
Yeah.
Right, so that's 310. What's the angle measure here? 50. So now let me go and do this. Let's say I have a 264 degree angle like that. We'll just call that 264 degrees. That's not a reference angle, because the reference angle is always going to be acute and positive. I mean, I've only given you 2 examples, but I've given you the definition. It's always acute and positive. So what would the reference angle be? Meaning, we make a right triangle like that, right? What's the reference angle that makes the same right triangle? Meaning, what's the right triangle in quadrant 1 with the same angle measure? Okay, so think through that for a second. If you want to write it down, you can, or you can just have it on the top of your head. What's the reference angle? So the big angle was 264 degrees, but now I'm asking for what's the acute positive angle? What's the reference angle that would refer to that 264 degrees? Okay. All right. What's the reference angle for that?
84.
84 degrees. You bet. Where did you get 84 from, Walker?
Well, like most of the things, 180 degrees.
Yeah.
But we just want the acute, so you can subtract 180.
Yep. So it'd be 180 degrees to get to there, and then subtract what? From 264. And so you get this as 84 degrees. Now the picture doesn't look great, but that's 84 degrees. Therefore, you would have a 84 degree triangle over there, like that. Yeah. So 84 would be our reference angle. So what that refers to is that any reference angle, all the ratios are going to be the same for when we talk about sine, cosine, and tangent, except for the fact that there will be some issues with the positive and negative stuff going on, which we'll discuss here in a second. Okay. So let's go ahead now. Also, we're just doing degree measures, but I could give you a radian measure, and instead of subtracting 180, you would subtract pi, right? Or instead of, and so you'd have to figure out that out with pi, which can be challenging just because we don't use pi's all the time. So now let's talk about, so we've talked about a reference angle. It's always acute. It always refers to how many other angle measures. A reference angle refers to how many other angle measures? Three, always, because it's an acute angle, and so it's going to always have three other triangles it associates itself with. So let's think about, though, now, we're going to transition for a second away from that, and then talk about the unit circle. And we're going to talk about 30, 60, 90 triangles and the relationships thereof, and then talk about 45, 45, and 90 triangles. So in a 30, 60, 90 triangle, do you remember the ratios that we talked about? Okay. If the hypotenuse is 1, there we go. What's the measure of the shorter side?
1/2.
1/2. It's half as big as the hypotenuse. And then what's the measurement of the longer side? Square root of 3 times longer than the shorter side. Yep. So it'd be 1/2 times square root of 3, which is root 3 over 2, right? Mm-hmm. Now you could, let's say you're like, well, what if we use different measures? Okay, that's fine. We can do different measures. We'll still say 30, 60, 90, right? And then let's use some different measures. The different measures would be, let's say we say this is 10. If the hypotenuse is 10, what's this side length? 5, because it's half as big always. And then what's this length here? 5 root 3. Okay, so 5 root 3. That'll all, I mean, you can always measure. You can measure with a ruler or something. It'd be hard to measure root 3, right, with a ruler, but it will always hold true. That always holds true. So then we talk about, well, what happens in trigonometry when we say, hey, what is the sine of an angle measure? We've been discussing this. The sine of an angle measure refers to the fact that you're asking what's the ratio formed of the opposite over the hypotenuse. Or what we've been talking about is if this was on an xy plane, there's your x and there's your xy plane, right? Where's your y? If I said what's the sine of 30, you're talking about what's the y value over the radius value of a circle. That's what what we're talking about with the y over r, x over r. You can also think of it what's the opposite over the hypotenuse, right? So if I said what is the sine of 30 degrees, it doesn't actually matter which one you choose because you're asking for a ratio, not a specific side length. You're asking for a ratio. So it doesn't matter. You would say, okay, the sine of 30 on this one is what? The y value, or the opposite, 5 over the radius, or the hypotenuse, 10. So you say the sine of 30 is 5 over 10, which reduces to 1/2. Here you say what's the opposite, or what's the y value over the radius, and it's going to be what? 1/2 over 1, which is just what? 1/2. And that's why when we do a radius on the unit circle, we talk about the radius is 1, because then you're dividing by 1 and it's easy. Okay. So the sine of 30 is 1/2. The sine of 30 is 1/2. So what's the sine of 30? 1/2. What's the sine of pi over 6?
1/2.
1/2, because pi over 6 is the radian measure of 30 degrees. You gotta know that, right? Eventually, you should be memorizing that by now, so that it's easier as you start to go, as you like do problems in the book, as we reference things up there. Okay, so if we know the sine of 30 is 1/2, let's think about this. So this right here, 30 degrees, the sine is 1/2. Now, 150 degrees. What is the sine of 150 degrees? You don't need a calculator, you just need to think through the triangle. So what's the sine of 150 degrees? Well, 150 degrees makes what type of triangle? 30, 60, 90. And you're looking at the y value over the r value, right? So what's the sine of 150 degrees? 1/2, absolutely, it's 1/2. Now we say, okay, we got that down. What happens when we get, what angle measure gives us this right here? What's the big angle?
210.
210. You say, okay, what's the sine of 210 degrees? Okay, and we say 1/2, and we think, okay, wait, it's going to be negative, because what's my y value? My y value is negative, so then it would be a negative 1/2 ratio. Now this is only applying to, not like when you're, this is applying to problems that you're looking at a coordinate plane, not like, hey, I'm going to be drawing a triangle for doing construction, and then you're like, I get a negative 1/2 length, that doesn't work. Okay, right, So, but for the circle, this is what we're referring to, right? So that's a negative 1/2. And then what's the last one we would do? What's this angle measure all the way around to there? Sine of what? 330. What? 330, what's the ratio? Negative 1/2. We got that. Nice job. Okay. So negative 1/2. Now, okay. What does that mean for us? The ratios are all the same, except you change the sign and the sign, S-I-G-N, right? Negative, negative. So what you'll see is problems, I can only leave that up there, but let's come back here to the reference angle idea, is that they will say, write in terms of the reference angle. So when they say write something in terms of the reference angle, they are not actually looking for you to write the ratio. They don't want you to punch it in the calculator, hit enter, and come up with a decimal. They want you to write the trigonometric expression in terms of its reference angle. Let me give you an example. Well, they actually wouldn't give you this, but let's just pretend. If they said sine, we'll call this number 1. So write this in terms of its reference angle. You're not looking for 1/2. That's the ratio. They want the reference angle. Is 30 degrees the angle that refers to the other 3 angles?
Yes.
Yes. So you're like, done. This is a reference angle because it's acute and it's positive. Okay, let's pick something different. So you wouldn't do anything with that. They won't ask you that. But they would do something like this. What is the sine of 150? And they want you to write that in terms of its reference angle. And you say, oh, well, sine of 150 is the exact same thing as sine of 30. Now I've written it in terms of its reference angle. Many people write 1/2. And it's like, no, that's not writing it in terms of its reference angle.
Yeah.
That's giving you what the ratio is. But then you get one like this, and they say, well, what's the sine of 210 degrees? And you say, well, it's not quite sine of 30. That is the ratio, but the ratio is messed up. It's opposite sign. So they still want you to write the reference angle. What's the reference angle? 30. But is sine of 210 and sine of 30 the exact same? No, they're off by just an opposite, right? So all they want you to do is they say, you know that sine of 210 gives you a negative 1/2. You have a negative value. And you know the sine of 30 gives you a positive 1/2. If this was the original value you have, you must represent it not as a positive, but you must represent it as a negative. So then the answer would be negative sine of 30. Not sine of negative 30, but a negative times whatever sine of 30 is. So this right here is your answer. Okay?
Yeah.
So then, let's again, because we know this is 1/2, negative 1/2, now a negative 1/2. So that's in our mind, but we don't have to actually know the ratio to do the reference angle idea. Meaning, if I gave you, we'll call this number 4, if I gave you sine of, let's go with 137 degrees. Now, you don't need to know the ratio, so you don't need to use your calculator to go sine of 137, and you're not gonna, who cares about the ratio? You only care about what's the reference angle for 137. So think through, just kind of like we did with the 264, idea. Start with what's the reference angle, and then we'll worry about positive and negative. So, what is the reference angle for 137? 43? Okay, 43, because that's, you went to 100, we're running out of space to draw pictures, but you went 137 degrees. How many degrees were left right there? 47 degrees. So that's the acute angle, therefore 47 degrees, right?
That's 43.
Yeah.
So 43, I'm sorry, 43 degrees, okay. So you went 137, there's 43 left. So now, since we're dealing with sine, what are we going to put? Sine, and then you just have to ask yourself, is sine positive in quadrant 1 always, right?
Yeah.
But more importantly, then you're saying, wait, is sine positive in quadrant 2?
Yes.
Yes, so if you hit your own, and you can test it by, you can do it on the calculator and say, what's my answer? It's a positive something. What's my answer? It's a positive something, and they're actually the exact same. So then, let's get away from that and say, okay, hey, cosine of 137. Now we're changing the ratio. We don't care we do care what the ratio is, but not the specifics of it. We care if the ratio is positive or negative. What is the reference angle for 137? 43. So now you got a 43 going. You know you got to keep it as a cosine because that's what you're referring to. So cosine, now you just have to think though, wait, is cosine of 43, cosine of 43 is always positive. These ones are always going to be positive when you get in terms of the reference angle. So now though, you got to think through, is cosine positive or negative in quadrant 2? Cosine is, let me come back to one of our pictures over here. Cosine is x, right? So cosine is actually negative. So this ratio, if you punch it in your calculator, is negative. When you punch this into your calculator, it is positive. Therefore, what do I need to put right here? A negative sign right there. Okay. But many people will actually just write the ratio. Okay, so then let's test our knowledge here. Sorry about all the chaos here. Now, we say, okay, cosine of 3.75. And you're like, ooh.
That should already be a reference angle.
Except for the fact that it is in what mode? Degrees or radians?
Radians.
Radians, yeah. Now granted, over here I was not writing degrees, which I should have been. I've splattered degrees on some of the stuff. This right here is in what mode?
Radian.
Radian mode. Okay, find the reference angle for that.
Oh boy.
Oh boy, you might need a calculator. Because your reference angle will actually be a decimal form. Because it's not a nice neat unit circle pi over 6 or something like that you can subtract and say, oh, it's 5 pi over 6 or pi over 3 or pi over 4 or something. It's going to be a decimal value because that's not an exact pi. Well, yeah, it's not in terms of pi, so your answer won't be in terms of pi. Yeah. It'll be something else. It'll still be cosine something. Okay. All right, what did we get approximately? Because right, you're gonna end up with a dot 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 dot. What did you get approximately for the reference angle?
I got 0.608.
0.608. Okay. I like that. I don't know if other people do. Let's
Not
check it
really
out.
that, but I think I did it wrong.
Yeah. I think that is correct.
Okay.
So remember, you got to know where 3.75 lands in terms of radians, right? So what is 3.75? Well, remember radians. This is 0. This is pi over 2. This is pi. Now that's why I told you to memorize the decimals. 3.14, 1.57. What was this one? This is 3 pi over 2. What's the decimal on that? 3 pi over 2? 4.71. I think that sounds about right. Okay.
Yeah.
So what you know is once you got those spots memorized, then you
Yeah.
can quickly say 3.75 is going to go over here somewhere. And so then you said this is 3.75 radians. Therefore, what is the gap between this and this? Well, you're just going 3.75 minus pi.
Yeah.
Which, if you just go 3.14, it would be 0.61. But if you do the whole pi, 0.608 dot 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 dot, right? So that whether you round or not is actually that important right now. We're just getting. So where did we get 0.608? We did 3.75 minus pi. Then you said, aha, my reference angle is 0.61. That angle right there. And then, which you know is acute and positive because it's positive for starters, and it's acute because it's less than pi over 2, which is 1.57. Then you said, well, wait a second, is it positive or is it negative? Well, you would know that cosine is always negative in quadrants 2 and 3, so therefore, what does this need to be?
Negative.
Negative, like that. Okay? So that should give you a big jump start on 7.4. We'll talk a little bit more about unit circle stuff. Make sure by next week, probably Wednesday, you have the whole unit circle sheet memorized.
Okay.
Does that make sense?
Yeah.
And Hazel, I'll tell you, we'll probably do 2 of those unit circle tests, the exact same as you have with quizzes, mid-chapter assessments, whatever you want to call it. And we'll probably do 2 of them and average your scores together. So if you get like a 60 and 100, we'll give you an 80. And then after that, we'll actually transition into doing some more intensive unit circle tests. So, yeah. So make sure by next Wednesday we have those memorized. Yeah.